My name is Antón. I am from Galicia, northwest of Spain. I have to say I feel like at home here in Malaga, probably because of the weather. I didn't know it was so similar to my area, a bit warmer maybe. I work as a principal software engineer at New Relic. New Relic is a company about monitoring and observability as a service. The thing I want to tell you is like 6 months ago, my company acquired another company, a startup called Pixie. They decided to donate to the Cloud Native Foundation all their services. And the thing is, when that happened, for me was like, well, this seems very cool. I started to trying to understand what Pixie was, having some conversations with some Pixie engineers. In my company, in New Relic, I am the engineer, the principal engineer responsible of Kafka. And when I started speaking with them, they asked me about use cases to monitor Kafka with Pixie. So what I did is propose them some challenges. And being honest, at that moment, I thought, this is impossible. You are not going to be able to monitor or to solve this problem with Pixie and with eBPF. But the thing is, I was totally wrong, and they did. What I discovered is this thing, eBPF, is super awesome. And I really think it's the most disruptive thing since containers and Kubernetes. And yeah, it's a personal opinion, but I really think it's a big thing. So I'm not here to tell you, to sell you New Relic or Pixie or any other thing, but what I want you from this talk is understand all the new possibilities we have with this particular technology. So let's speak a bit about the challenges and what I do in New Relic. New Relic is all about monitoring, and because of that, we are heavy users of Kafka. So how many of you know what Kafka, Apache Kafka is? Could you raise your hand? Okay, most of you, nice. So if there is someone who doesn't know what it's Kafka, it's just basically a place where we store data very fast so it can be consumed later. Just to give you some numbers of how much we use Kafka at New Relic, we ingest 125 petabytes of data per month. How much is that? It's hard to say, but maybe messages. We ingest 3 billion data points, 3 billion messages per minute. So just during this talk, we ingest a lot of data. And the thing is, because we use Kafka at this scale, probably one of the companies using bigger more big Kafka clusters at the wall, we tend to put the technology in the limit. And indeed, at some point in our history, we were running a cluster of 275 brokers, nodes, with more than 20 gigabytes per second of throughput, and that's not counting replication. So it was huge, and it was painful, really painful. Because of that, we spent a lot of time improving monitoring, because in the end of the day, monitoring is what we do, because for me, it's free. I don't have to pay anything. Because I work for a monitoring company, I can use it. That's nice. So the thing I did was share some of those challenges with those engineers, and they decided to solve them using eBPF. In general, monitoring Kafka, it's kind of complicated. There are several ways. The most typical is using something called GMX exporter to retrieve the data from the Java virtual machine. But still, you need also retrieve the data from the GVM itself, from the operative system, and put all together to really understand what's happening. And which is even worse is Kafka is so good, it's so performant, because part of the logic is not in Kafka in the server itself, but it's in the clients. So to understand when there are problems, you need to have metrics from the client side and the cluster side. And I see people saying, yes, it's true, that's true. Yeah, it's true. Okay, so, and that makes things more complicated. So Pixie approaches this problem in a totally different way, using eBPF. So let's introduce what is eBPF. How many of you are familiar with eBPF? Raise your hand. Okay, I love to see that because you are going to be super surprised. So eBPF is a new Linux kernel capability. Okay, as Docker at the moment, it was basically also new Linux capabilities. BPF is something new we have in the Linux kernel. And basically, it's something very smart. It allows us to subscribe to events in the kernel. So we can tell to the kernel, each time something happens, notify me. And there are many different things. It can be a packet arriving from the network. It can be a program opening a file. It can be a process doing a syscall to a library. So a lot of things. I know, because I did this talk in other conference, someone is going to tell me, yeah, Antón, that's very cool, but there are other things which already provide that functionality, like git trace and blah, blah. Yeah, that's true. But eBPF has two things which make it very special. One is performance. The overhead of obtaining that information, it's really low in comparison with others. And the reason of that is because under the hood, eBPF uses a virtual machine as Java and other similar platforms. So basically, it's able to do this just-in-time compilation and to apply all those optimizations to make sure it's not taking too much CPU in that server. The other benefit it has is safety. The Linux kernel is super complex, and at the same time, it's a critical part of our services. So we don't want to do dangerous things inside the kernel. And that was the problem with other options and with other technologies. What we do with eBPF is we write our eBPF program, it's compiled to bytecode, and we send it to this virtual machine. And the virtual machine has a lot of safeguards to make sure that program is not going to break anything in the kernel. So if it is doing something dangerous or having a bug or whatever, the virtual machine is going to say, no, 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 you cannot run here. And it's going to reject the message. So now we can tell with something called a eBPF proof, whatever that happens, execute my message, execute the event, execute the program in the virtual machine with the logic. And then if you want to do more things, send it to the user space, so whatever application is running in the server, so you can act on it and send that information to other place or react with any other action. So that's basically eBPF, right? So now, how we can use eBPF? There are different ways. The most low-level way is with something called BCC. BCC is a toolkit to create programs using eBPF. I'm going to give you some examples just so you can see some use cases. This I/O latency histogram, you can create a command line for that, so you can see all the latency access in the disk. This is key for Kafka. You can see each time a new process is launched in the system, in the operative system, or a new TCP connection is open, or you can create custom traces. The thing with BCC is it's super powerful, but you have to learn C. You have to know how to code in C. I don't do that from Science Day University, so I have no idea. You need to know how it works eBPF and how it works the Linux kernel. There are places here if you want. So it's not easy to use. There are a couple of wrappers in Python and Lua, but it's still doing that is not easy. Another tool is BPF trace. BPF trace has a domain-specific language, a DSL, so you don't have to learn so much. Only with this DSL, you can build very powerful command lines. And just with some one-liners of BPF trace, you can see the files opened by a process, the syscall called by a program, how many bytes are read from a specific process, and so on and so forth. So it's very powerful, and only with this DSL, you can have a lot of information. But still, it's in the command line, and it can work for some things, but not for others. If you want to use it in Kubernetes, there is kubectl trace, which basically is using BPF trace under the hood. So you can run those commands in every service deployed, in every pod service deployed in Kubernetes. So it's a good way also to extract easily information from Kubernetes and take advantage as Kubernetes as a standardization layer. So more options, higher level options. eBPF exporter. This is an open source project by Cloudflare. They are huge fans of eBPF. And basically the idea is you use BCC under the hood to extract that information and to send it to something called Prometheus. And from Prometheus, you can query it with Grafana, New Relic, or any other service. So now you can query the data, you can have your dashboard. It's just easier to use. But still, this thing doesn't understand your services. If you are monitoring a database, if you are monitoring something like Kafka, if you are monitoring an application server or whatever, you need to build the logic to really extract that information. So now, let me introduce Pixie. So Pixie, it's totally open source. You can use it by yourself, host it yourself, totally free. It's going to be free forever because it's part of the Cloud Native Foundation. Basically, what we do with Pixie is we deploy it in a Kubernetes cluster, and it's going to be able to extract information of all the services deployed in Kubernetes without any code modifications and without any redeployment. So it's like magic. You have your services in Kubernetes, you deploy this thing called Pixie, you have metrics of absolutely everything in Kubernetes. The other thing which I think is really interesting in Pixie, it's able to understand some of your applications. So if you have things like Kafka or a HTTP server or HTTP service or MySQL or Postgre or Redis or a long list which is growing all the time, it's going to be able to interpret those things and provide specific metrics for them. Okay? I will explain later how it's able to do that. So, what is the approach of Pixie? How to do that? Basically, what is going to do is deploy something called a Pixie Edge module, which is just a pod, a service, in every node of your Kubernetes cluster. And that service is going to capture data using eBPF. It's going to parse that data to interpret that data and put it in a table. And now, once it's stored in that table in every node of your Kubernetes cluster, now we can query that data with an UI. So you can use a managed service like Pixie Cloud or New Relic, or you can just deploy that UI in your own Kubernetes cluster and use it for query the data. Now, I'm going to use Kafka as an example because this is what I know about. In the case of Kafka, what we did is Pixie detects all the Kafka brokers. A Kafka broker it's a node, basically. So it's going to detect all the Kafka brokers deployed in Kubernetes, and it's going to be able to listen all the traffic sent and received from that node. So if there are any any client reading or producing to Kafka, because it's reading in the broker side, it's able to detect that, to parse those messages, and to interpret them to provide insights. So Kafka, as it happens with Postgre and other distributed systems, has an internal protocol, which is very efficient for sending asynchronous data. But it's specific for Kafka. So what these engineers did is listen all those messages, parse them, and extract the information they were interested on to generate insights. So we'll see later how it works. So, time for the demo. Well, a couple of things. What I did just before the talk, okay? It was, first of all, the first line, I created a Kubernetes cluster in Google Cloud. I use Google Cloud because I am a Google Cloud expert developer, and I don't know what. So they give me free credits, and that's nice. Thank you very much, Google. Love it. But you can also use AWS, Azure, or whatever other Kubernetes service you want. Then I deployed Pixie, and look at that. It's just a command, px deploy. You don't have to do anything more than that. Px deploy. I'm suffering with this thing. Ow. Is it working? Yeah, okay. So just this command, px deploy, and boom. Now you have full monitoring of all the services in your Kubernetes cluster. And then I created a namespace, just a way to keep things organized in Kubernetes. And I deployed something called Streamsy. Streamsy, it's another project from the Cloud Native Foundation. And it basically allows us to create Kafka clusters in Kubernetes. So as you can see, just one line. Now we have this operator deployed in our Kafka cluster. And then the last line is to create our cluster. And yeah, I know. I attended the keynote today, and I know Hari is hating me because I am doing all those things with Kubernetes and Streamsy and a lot of layers on top of them. Probably my demo is going to fail because I deserve it. We'll see. So, yeah, demo time. What I'm going to do, well, let me show first Pixie. So this is Pixie. Basically, what we have here is we can select what Kubernetes cluster we want to see. We can select how long are the metrics we are seeing. So right now we are seeing the metrics for the last 5 minutes. We can see a service map. So this is basically all the services I have deployed in Kubernetes, which are speaking with each other through HTTP. So Pixie under the hood is able to detect all those HTTP messages and provide metrics about them. So we know how they are being connected, and we can even click on them and have things like the throughput, the error rate, the latency of those things. As I said, we just use one command, px deploy. So if the Mac allows me to go down, okay, we have also more information about Kubernetes. In this case, I have 2 nodes, the namespaces, and how many pods, and that type of information I have. Okay. Is it okay from the back? Okay. We have access to all the services, and we also have access to all the pods. The pods are the applications which are running in Kubernetes. So I can see the CPU use, the disk, the number of containers, and I can even click on any of them. Let me choose, for example, I don't know, this one. I have even more information. So this is for a specific pod. I can see all the HTTP requests, errors, and latency for that pod. I can see the CPU uses, the containers, the processes. We can see the network, how many kilobytes or megabytes are receiving and sending, the memory, more HTTP information, more pod information, and this, which I think is super cool, this is a flame graph. What is a flame graph? This is basically telling us where our application or our service is spending time. So if our services is slow for whatever reason, because we have an infinite loop in our code, because we forgot about it, what we are going to see here is we are going to be able to see here where our application is taking time. And this is building without any instrumentation and in real time. And we can do this for Go applications, for more languages, and now as an experimental feature, even for Java. Okay, we can do all those things. So, but there is no Kafka here yet. So let me continue with the presentation and speak about Kafka. And the first challenge I have for these engineers. So for me in New Relic, we have a lot of teams, a lot of people using Kafka. And one of the problems I have as the administrator of the platform is Kafka is really distributed. So there are a lot of different applications reading and consuming from Kafka. They are using different technologies, most of them in Java, some of them in Kotlin, different versions sometimes, which makes my life harder when I want to upgrade the clusters. And just sometimes answer the question of who is writing data to this topic and who is consuming data from this topic is not an easy to answer question. So how our data flows through the organization is not something we can do easily with our current monitoring. So that was the first challenge I have for them. Hey, help me understand how my data is used in my company. And this is what they did. So first of all, I'm going to launch here an application which is sending data. I hope. Please. Come on. Yeah, here we go. And another application which is reading data. Okay, it's just random data, but it should work. Now, here we go. Let's go to Pixie. And here we can choose different scripts, so different things we can see in Pixie. I'm going to type Kafka, but you could type, I don't know, MySQL, whatever. I'm going to go to Kafka overview. And here we go. This is built in real time. And basically, they detect, I launched a producer, an application sending data called producer1, which is sending data to a topic called Pixie. I'm not very original. And it's reading that data. There is just one consumer reading the data called consumer test1. So kind of a hello world application, but ¿sí? Guay. Vale. Now, one of the things we can do here is, if I'm able to click, yeah, we can see how many records it's sending and how many kilobytes and megabytes it's sending per second, which is a super useful information for teams doing streaming. And we can see the same thing in the consumer side. So we can see our applications, how many records are reading per second, and how big are those records. We can have a list, and again, in real time, without any instrumentation, without modifying Kafka at all, we can have a list of all the topics with the number of partitions, the number of producers, the number of consumers, and more information, all the brokers, in this case we have just one, and how much load they have, the network, and so on. We have more information about the consumers and the producers, and we have also at the pod level. So we can see not only from the consumer, from the Kafka perspective, but also from the Kubernetes perspective, how the pods are interconnected, okay? So this is kind of magic. Now I want to show how Pixie is able to build those things. So if I go to Kafka again and Kafka data, what we are going to see is this table. Basically, all those messages we see here are the messages of the Kafka protocol, are the messages, the metadata, which is sent between the brokers and the clients to understand each other. Okay, so we have things like, hey, I'm going to produce data to you, or things like, not at the moment, but I will see them later, like, hey, give me all the metadata, so give me all the information you have about the cluster. So all those things are here. eBPF is able to store them, and we can see them here in the right. So we have access to what is the source, who received the message, who sent the message, and the message itself. And with that, we can understand Kafka at the lowest level and see what was happening. I will explain more things later, but let's go with the next challenge first. So, next challenge, Kafka consumer lag. How many of you are familiar with Kafka consumer lag? Raise your hand. A fair amount of people. Okay, Kafka consumer lag is the most important metric in Kafka. And it's the metric which is waking up during the middle of the night every day. Or this is my case and the case of the people who works with me. So what it is, basically, we have Kafka. We put information in Kafka, and other processes are reading that information. The thing is, if something happens, maybe the producers are sending more data, maybe the consumers are not processing all the data as fast as they should, or maybe there is a bottleneck in the Kafka cluster side, what we are going to have is a situation where the consumers are not reading the last message, but there are messages, amount of messages pending of being consumed in Kafka, right? So basically, that list of messages which should be consumed as soon as possible, it's growing. That thing is the consumer lag. So typically, what we want to have is a consumer lag as much low as possible, because if we have consumer lag, that means we have latency in our pipelines, and when we are doing streaming, latency is something we want to avoid as much as possible. So the thing with consumer lag is, this is something we typically have in Kafka with an external service. So many companies use something Burrow from LinkedIn. I have no idea how they choose that name. And it's a very nice library, but only provides consumer lag in offset, in number of messages. Other companies use Kafka Lag Exporter by Livevent. The difference with the other one is Kafka Lag Exporter provides the lag in seconds. So for a thing in New Relic consuming from a topic, if you receive an alert in the middle of the night saying, hey, there is a consumer lag of 100 messages. Is that a lot? Is that a problem? 100 messages is, they're not really something you can easily measure. But if you receive a message saying, hey, you have a consumer lag of 30 minutes, that's something our engineers understand. Because that means in their pipeline, there are 30 minutes of latency. Because also in Kafka, we typically, after an amount of time, we start discarding data. So if we have 30 minutes of what we call retention, and we have 30 minutes of consumer lag, that means we are losing data. And our customers are not happy when we lose their data. So we try to not do it never. So consumer lag in seconds is super useful. But at the same time, it's also very tricky to calculate that number, because we have to extrapolate how fast our services are reading in every moment and how many messages are remaining. So, and we have to, in our case, we developed a service similar to Kafka Lag Exporter, but in Java, because we don't know how to develop in Scala anymore. So we created this one. And what I told to those Pixie engineers is, okay, this is working for us, but if you could make our life easier, that would be great. So what they did? We can we have Pixie, and what I'm going to do is generate some artificial lag. So I go to my consumer, I'm going to stop it. So if it's not reading, there are messages which are waiting in Kafka to be consumed, and I'm going to, no, that one, prod one is not what I wanted to launch, the consumer, please. And I'm going to launch it again. Now, if I go to Pixie, I'm going to change to a different script, Kafka, and have this Kafka producer consumer latency. I'm going to choose my namespace, which is Kafka, big surprise. I'm going to choose the topic, Pixie, and here we are. This, my friends, is consumer lag. So basically what we have here is only one partition, and we have been reading, no consumer lag at all. I stopped the consumer, and then boom. During 22 seconds, information was sent to Kafka, but nobody was reading from it. Then I started the consumer again, and boom, again, the consumer lag goes to 0 because we started reading so fast that all the messages were gone. So this is consumer lag. And as I said, this is super useful for all the teams doing streaming. So here we have information about the producers and consumers. The thing is how Pixie is able to measure this. This Burrow and the Live exporter that are using the Kafka APIs, they are consuming from an internal topic called consumer offset to extract that information, but Pixie is not able to do anything like that. They have to do it with eBPF at the Linux kernel level. So how was that possible? Well, first of all, I want to introduce here something called the Pixie script and editor. This is basically the code which is building all the functionality we can see in the dashboard. Okay. So you can go here directly, you can edit it in real time, you can make changes, you can create your own, you can share them. So it's super, super flexible. It's kind of similar to Python, but with some limitations because in eBPF we cannot do many things because they are not safe. For example, loops. There are some workarounds, but loops are dangerous for the kernel, so we are not doing loops. So here in some place, I think it's line 100, here we go, it's going to tell us how it's calculating this time, which is basically the difference between the consumer and the producer. So if I go to the Kafka data script again, we can delete that one. We can see here our producer is sending a metadata message called produce. Let me see if I can do here. So we have our producer sending to our broker a message saying, hey, I want to send a batch of messages to a topic called Pixie to the partition 0. Partition is the level of parallelism in Kafka, is how we split the topics. And the broker answers with, okay, I stored that information in the topic Pixie, partition 0, in the position where, an ID which allows us to know where is stored that information, 160. Now, if I go to fetch is the same thing, but from the consumer side. The consumer is telling, okay, to the broker is telling, hey, please give me the messages from the topic Pixie and the partition, and it's going to tell them also the offset. So what we are going to do with Pixie is detect this doesn't work for my head. And I think it's because I have a very big head. It's going to calculate the difference between the first message and the second message. If that time grows, that means it's taking a lot of time for the consumer, and that means we have consumer lag. Okay, so that's exactly what we are doing here. It's just tracking the IDs of a specific batch, when that batch has been produced and consumed, and calculating that time. And that gives us a perfect metric of consumer lag. Okay, I know I'm going very deep in Kafka. That's my passion. Sorry about that. Okay, let's go with the next challenge, which is Kafka rebalances. So this is a typical source of pain for everyone using Kafka at scale. As I said, when we're reading from Kafka, Kafka uses the concept of partition. So basically, in this case, on the left, we have 3 partitions. When we want to consume from Kafka, we usually don't have an application of just one instance. We have more than one, right? And those applications are grouped in something called a consumer group. So in this case, we have a consumer group on the left of 2 instances. Because one instance can read only from one partition, we cannot have more than one instance reading from the same partition. We need to assign somehow partitions to instances. So this is a process done between Kafka and the consumers. And in this case, Kafka and the consumers have the agreement of consumer instance 1 is going to read from partition 0, but consumer instance 2 is going to read from partition 1 and partition 2. Okay? But the thing is, consumer instance 2 was not feeling very okay because it's reading from 2 partitions, and that's a lot of work. So it was, the load was quite high for that particular instance. So we receive an alert in the middle of the night because the CPU is too high, and we decide to launch consumer instance 3. So now Kafka, the Kafka broker, and this application of free instances have to renegotiate how the partitions are assigned. And after that renegotiation process, the partition 2 is not assigned to instance 2, but to instance 3. That process of renegotiation is a consumer rebalance. And there is nothing wrong with it, but the problem is when we are doing that negotiation, all the consumer instances, at least by default, have to stop consuming. So basically, they stop consuming, they make an agreement of what partition is going to read for what consumer instance, and once there are agreement between them, they start consuming again. So this is very painful, especially if your applications are not very well tuned. It's not easy, I have to say. So this is a typically source of pain for many engineers because this is a very simple use case, but we have in some cases 500, 600 instances reading at the same time. Those rebalances may take a lot of time. And that lot of time is latency in our pipelines. That means problems for our customers. So we're trying to minimize that as much as possible, but it's so complex. Sometimes understand all this process is not really easy for our engineers. So that's what I told to these Pixie engineers is, could you help me to help the engineers doing streaming at New Relic to provide a better understanding of what's happening when there are rebalances? So, and that's what they did. So what I'm going to do is generate some rebalances. And for that, I'm going to launch a new application. and I'm going to kill this one, and I'm going to launch it again. Now, if we go to a new script called Kafka consumer rebalancing, this is what we can see. We can see we have a group of consumers called test, and that group has 2 members. And we can see also there were 2 rebalances, rebalance 10 and rebalance 9. During rebalance 10, one of my instances stopped consuming during 4.6 milliseconds, and the other one stopped consuming during 1.4 milliseconds. So this is a really good information for engineers doing that, because just knowing what happened, what consumer instances is reading, how long it took that rebalance, it helps a lot to understand the process and to do the tuning required to minimize that time. So, and as I said, obtain that information in other ways is super hard to do. So how Pixie is able to do this? Basically, looking at the Kafka protocol and understanding it. So this process is a bit complicated. I'm not going to go into detail, but I would love to explain it if you want after the talk. Basically, when we launch a new instance, this instance is going to send a join group message saying to the broker, hey, I want to join, I want to read, right? And this, the broker is going to notify to the other instances of that situation, hey, there is one of your friends who wants to join the party. So all of us we are going to stop, and that's the response, basically. So here it will be a join group. Here it is with a response saying to all of them, okay, let's renegotiate the partitions. And to one of them is going to tell it, hey, you are the leader. So the leader in the consumer means one of those applications, consumer applications, is going to decide what partitions are assigned to one instances. So, and this is kind of counterintuitive for many people working with distributed systems, because not the cluster who decides that, it's the consumer. Then this leader is going to send a sync group message saying, okay, these partitions are assigned to this consumer instance, and all will send the same message, all receive the difference, the answer from the protocol, from the broker, and boom, they start consuming again. So to calculate the time of the rebalance, what they are going to do is calculate the time between the consumer send the join group and the consumer receive the response of the sync group message, which is calculated like the time plus the latency, which is also part of the message. So again, we have access to all that low-level information, and we can extract things which are not pure metrics, are specific of Kafka in this case. Just closing, I'm running out of time. Kafka, it's hard for monitoring because it's super powerful, but that also means some things are quite complicated. eBPF opens a new world of possibilities. This was in my context, but if you think in your own, the type of things you do every day, I'm pretty sure you are going to find really use cases for eBPF. Pixie, open source, it gives you instrumentation, monitoring, observability without modifying any of your code, without redeploy your code, very, very easy to use. Even it's able to understand some of your applications, databases, and so on. So That's all from me. Thank you very much for your time. I hope you like the talk.
Okay, thank you very much, Anton. Questions maybe from the audience? Oh, I see a lot of hands. That's good.
So just a simple one. Which data storage does Pixie use and why?
To be a simple one, I have no idea, to be honest. I don't know. I know you use something which is running in Kubernetes, but I am not some of those Pixie engineers, and I never ask. I should, but I don't know, to be honest. Sorry.
So question at the end.
This is also my Twitter account. If I'm not able to answer some questions specifically about Pixie, my thing is Kafka, really. You can ping me there, and I'm happy to ping those Pixie engineers so they can give you all the details, okay?
Does Pixie have any inbuilt functionality to allow for alerting based on top of the metrics? Or does it connect to like Prometheus or anything?
Sorry, you have a much better English than me. Could you repeat the question?
Sorry, what did you say?
You have a very good English.
Okay,
not so good.
sorry.
Could you repeat the question?
Does Pixie have any inbuilt alerting or integration with any tools such as Prometheus?
Yeah, really good question. Pixie doesn't have alerting by default. There are two options here. One is you can use a managed service for Pixie. For example, in our case, New Relic, we are providing that. So you can use Pixie and then integrate it with all the rest of the New Relic capabilities, and you will have alerting, incident management, machine learning, and a lot of things. So that's one option. The other option is Pixie is totally open source, and it's using something called OpenTelemetry, which is basically a standard way to send metrics. So with OpenTelemetry, you should be able to integrate Pixie with other things like Prometheus or other UIs and other that type of things. Okay, so it's pretty standard. The idea is keep that as open as possible because it's also part of the foundation. So that should be perfectly possible. Okay, but by default, alerting is not provided.
Okay. Any other questions from the audience? Oh, yeah.
So my question is, does it behave? Sorry, my question is, does it behave properly if you are using things like TLS or Istio to cipher the communication?
Yeah, because it works at the pod level. If you use Istio, if you use Cilium, which is kind of a very close project to it, all those things should work. As far as I know, they shouldn't be a problem. Okay.
You use TLS. You're using TLS to communicate between the.
Yeah. If you are using TLS, and I'm not aware of the details exactly, but my understanding about that is what they're doing is they are intercepting as part of the TLS. They are going to have invocations to syscall to the operative system. So they are intercepting those syscalls to be able to then later decrypt the messages and interpret them. I have no idea how it works. I cannot give you details. I never use that, but it seems like it's possible, and they are pretty optimistic about it. Okay.
Okay. Yeah.
So first of all, does New Relic support this kind of monitoring on Kafka, or?
Yes, and New Relic provides. Pixie is part of the native foundation, but New Relic is contributing a lot to it. Some of the engineers implementing this Kafka feature are working for New Relic. That's how I was able to contact them. But you can use New Relic if you want, or you can use other. You can host Pixie by yourself if you prefer, and everything should work. The scripts to use Kafka are open source, are part of the GitHub repository. You can open them, modify them, and totally public. Okay, and they will love contributions if it's something you would like to do.
Okay. Okay. Any final question, maybe? Let me see. No, I think we're done. Okay, then I would like to thank Antón for his great presentation.
Thank you very much.